Okay, so I have a 3-equation system with 3 variables. We like to refer to this as a 3x3 system. It has a potential of having a unique solution since we have at least as many equations as we have variables. So here is what I'm going to do. I'm first of all going to choose a pair of equations, and I am going to choose a variable to eliminate for that pair of equations. So here is what I'm going to start with. So I have the system x plus y minus z equals -4 and 2x plus y minus 3z equals -10. I can choose any of those 3 variables to eliminate. I'm going to go ahead and choose, let's go ahead and go with y. So I see that my y terms both have the same leading coefficient, 1, and the least common multiple of 1 and 1 is obviously 1. So I am going to choose to multiply equation 2 by -1 and leave equation 1 alone. So that means I have x plus y minus z equals -4, and I have -2x minus y plus 3z equals 10. So I chose to have opposite leading coefficients so that I can add. I like to always add whenever possible because we tend to make less mistakes when we add signed numbers. So I have 1x and -2x, that adds to -1x, +1y and -1y, that adds to 0y, -z plus 3z, that adds up to 2z, and -4 plus 10 is 6. So I will go ahead and call this equation 4. A lot of times we like to label our equations so that we can keep them straight. The original 3 equations I would call equations 1, 2, and 3. Okay, so now I am going to go back to the original system, and I am going to choose a different pair of equations. So I could either choose equations 1 and 3 to work with, or I could choose equations 2 and 3 to work with. It may be a little bit easier to work with equations 2 and 3. So I will go ahead and pick up there and use those 2 equations. So I have the system 2x plus y minus 3z equals -10, and 3x plus y minus 4z equals -11. So the big deal, the most important point here is that I eliminate the same variable that I eliminated at the previous stage. So since I eliminated the y's in the first step, I now need to make sure that I also eliminate the y's at this stage. So I have the same leading coefficients on y that I had before, and so I'll do the same thing I did before. So I will multiply the second equation here in this system by -1, and I'll leave the first equation alone. So 2x plus y minus 3z equals -10, and -3x minus y plus 4z equals 11. So since I have opposite coefficients, it will make sense to add the equations. And so I have -x plus 0y. -3 plus 4 is +1, so plus z equals -10 plus 11 is +1. So this is my equation. I'll call this equation 5. So now what we need to do is we need to put equations 4 and 5 together. So if I take equations 4 and 5, I now have the system -x plus 2z equals 6, and negative x plus z equals 1. So I decide which variable I want to eliminate. I'm going to go ahead and go with, just for fun, I'm going to go ahead and eliminate z. So since the first coefficient on z is 2, the second coefficient on z is 1, I want to find the least common multiple. The least common multiple of 2 and 1 is 2. So I want one of those to be a 2, and I want one of the coefficients to be a negative 2. So I'm going to go ahead and multiply the second equation by negative 2. So I have negative x plus 2z equals 6, and 2x minus 2z equals negative 2. So I can add those two equations. That gives me x plus 0z equals 4. I now have an answer for x. So now I'm going to take that and I'm going to plug it into one of these two equations. I'll go ahead and just choose the first one. So I have negative 4 plus 2z equals 6. I will go ahead and add 4 to both sides. That gives me 2z equals 10. Divide both sides by 2. I now have z equals 5. So now I have two answers. So I have x equals 4 and I have z equals 5. So now I can take both of those answers. So I'll take the x equals 4. I'm going to go ahead and plug those into the first equation. Here's the equation I'm plugging it into. So x plus y minus z equals negative 4. That x equals 4 and z equals 5. So now I'm going to plug those in. 4 plus y minus 5 equals negative 4. I will combine like terms, so I have y minus 1 equals negative 4. So then I have y equals negative 4 plus 1. So y equals negative 3. So the last thing to do is to check. So I will use the second and third equations for checking. So the second equation says 2x plus y minus 3z equals negative 10, and I want to see if my numbers make that true. So I am plugging 4 in for x and negative 3 in for y and 5 in for z, and I want to see if the answer is negative 10. That gives me 8 minus 3 minus 15. 8 minus 3 is 5, and 5 minus 15 is negative 10, and that is what I wanted to get for an answer. So that looks good. I will go ahead and do the same thing with the third equation just to be safe. The third equation says 3x plus y minus 4z equals negative 11. I am plugging in the three numbers that I have. So for x, I am going to plug in 4. For y, I am plugging in negative 3. For z, I am plugging in 5. So I want to see if the answer is negative 11. So I get 12 minus 3 minus 20. 12 minus 3 is 9. 9 minus 20 is negative 11. And that was the number that we were hoping to get. So we now know that the solution to the system is x equals 4, y equals negative 3, and z equals 5. Sometimes we will write that using point notation. So I have the coordinates 4, -3, 5. That would be a point in three-dimensional space. So if the three equations I am given are equations of planes, think of like sheets of paper, then those three planes intersect in that single point.